Are we the only thing between you guys and lunch now, or is that always a difficult spot to take? But Erica is very brave, so she won't have any problem with that. It is my real pleasure to introduce Erica Spotswood. So Erica is an applied biologist at San Francisco Estuary Institute. She has told you already, what some of the things that she's working on, and she'll tell you more. She received her PhD from UC Berkeley, and before that, she was doing some conservation work in Africa. In Central Africa and also in West Africa when she was in the Peace Corps. I had my first conversation with Erica about 2 years ago, I think, and since then, this first conversation produced amazing partnership and collaboration. Erica has embraced the urban forestry community, and we are embracing her too. Her Reoaking Silicon Valley book that she's going to tell us about it is a bestseller, although there are some free copies over there on the back table. So grab them while you can. And her presentations are in very high demand. Last week, she presented at the Western Chapter ISA conference. And in March, on Arbor Day, as a matter of fact, she presented at a mini symposium, urban forestry symposium, that our city forest and canopy organized for the county of Santa Clara. And this is where I took this photo. And this is, you can tell that Erica is an applied biologist, I think, because here she's applying her skills that she learned in Africa to carry a box full of her reports to the conference. And of course, behind you have, her boss, Robin Grossinger, and our very own Cindy Blaine leisurely strolling while Erica is doing Well, Erica is doing the hard work. So now Andy is going to talk a little bit about why he thinks that Erica's work is important.
Good morning, and thank you. As a practicing arborist, I work with West Coast arborists, and we take care of trees in many different communities throughout California. And it's interesting to see the threats, not interesting, it's scary to see the threats that we have with our California oaks right now. I mean, we all talk about the shot-hole borer, which is certainly hitting many of our different oak varieties. And West Coast arborists, the last couple of years, we've actually really ramped up our efforts towards plant health care and created a whole division. So currently we're working with the UC Extension people, with Keith and John Kabashima, and the best practices as they evolve in order to try and, reduce the spread of the shot-hole borer. On a personal side, and that's affected tens of thousands of trees that we've had to remove in Orange County parks and throughout Southern California. And on a personal side, for about over almost 40 years now, I've worked with a property down in northeast San Diego County, an old scout camp, 1,400 acres. And, for years we battled waves of bark beetle, and that culminated about 12 years ago with a really bad, die-off. We removed more than 1,000 pines and still had more brush, fuel loading, and dead material on the ground than we could manage, and ended up with a lightning strike that burned about 1,100 of the acres. It's been a neat process to watch the regeneration of all those trees, including, our fear that we would lose our coulter pines there. And we actually had a return of coulter pines for various reasons, and so we thought we were in good shape, and I went back to the camp about a year and a half ago and discovered gold-spotted oak borer. This year we sent in a data collector who collected about 1,500 sites in the main activity areas of camp, and just as initial startup, we know we have to remove over 300 trees, and we have many more that are infected. It was obvious. It was a movement of firewood that brought it to this kind of isolated valley that's within a chaparral area. you could see the points on the map and see the spread of the problem. And so we're obviously trying to save those oaks and protect them. So it's great work that in the oaks community on the other side, you know, I'm working with the Tree Care for Birds and Other Wildlife Project, and we know that lobata and agrifolia and these other oak species are keystone to, you know, those ecological environments that we have with wildlife habitat and everything else that comes. So it's exciting stuff to try and do what we can, and we're looking forward to Erica's presentation. So help me welcome Erica, please.
Thank you all for being here. Thank you to Catherine and Andy for that really nice introduction. Catherine came up to me after that photo was taken and said, so your boss, the guy with the other box behind you, he's carrying the lighter box, wasn't he? I said, yeah, that's right. So I'm going to start by introducing you to the Resilient Landscapes Program and to San Francisco Estuary Institute, recognizing that many of you probably aren't familiar with our organization. So first of all, we are not based in San Francisco. And second of all, we don't only work in estuaries. So our name is a little bit misleading. We do conservation, large-scale restoration and conservation planning throughout the state of California, and we're based in Albany, in the East Bay. And so our approach is we are a science synthesis and translation organization. So we fill a gap between academia, the science that's coming out of academic institutions like Cal, where I did my PhD, and practitioners across a variety of domains who have a need to harness the best available science to inform the actions that they're taking on the landscape, but don't have the capacity to do the work of synthesizing all of that literature and translating it into actionable guidance. And so there's a name for us. We're called a boundary organization, and the boundary organizations like us serve an incredibly important role in bridging the gap between academia and practitioners, recognizing that many academics and professors aren't actually doing that work of taking their results of their research and trying to figure out what it means for real landscapes, for real people, for real actions. So that's what we do, and we do it across a variety of different landscapes across the state, and you know, sort of moving from estuaries up to natural areas and through the urban landscapes in the middle, in the Bay Area. We work in a huge number of places, and we have a huge number of partners, and we generally work directly with state agencies, municipal agencies, and sometimes federal agencies, and increasingly we're also working with organizations like Google in the private sector to try to help them guide the actions that they're taking on their campuses in Silicon Valley. And so I'm going to talk about the reoaking report that came out in the fall of last year, and there are a couple of copies back there in the back, so anybody who wants them afterwards, feel free to take one. So what I'm going to do is I'm going to give you just like a really brief overview of this report, and then I'm going to turn to focusing on sort of launching a discussion that I thought we could have in the second half of the hour about just what are the challenges and barriers to implementing reoaking in the urban forestry context. I think that's the really important conversation that needs to be had. So if we can start from the premise that, yeah, probably most of us like oaks, but there's big barriers to actually getting them back into the urban landscape. So can we have a conversation about what those barriers are and how we might go about overcoming them? So, okay, so with that in mind, I'll start with just a brief overview of what this project is. So it's funded by Google through the Resilient Landscapes, the Resilient Silicon Valley Project, which is a kind of big effort that Google is taking to direct philanthropic dollars towards resilient planning for the region of Silicon Valley, recognizing that they have an impact in the region and that they want to do right by Silicon Valley in terms of environment as well as other sectors. So as with all of our projects, we had a really stellar technical advisory team. So these are the people, the scientists in the academic institutions that help us make sure we're getting the science right. And so the genesis of this project came out of something that SFEI does, which is to develop historical ecology, which reconstructs past landscapes and creates maps that document what these landscapes looked like at the point of large-scale human modification that happened, you know, in the 1850s when Europeans were arriving. And so we've done this. We did this over the past decade for the landscape of Silicon Valley. And what we found was that this landscape, before human contact, before significant European modification, was dotted with a big mosaic of different habitat types, sort of in a heterogeneous fashion across the valley floor. But the important note to make here is that the 60% of the valley floor was an oak, was a sort of a mixed oak woodland oak savanna dominated by Quercus lobata, the valley oak. And so with that background in mind, we said, well, okay, we know that oaks are foundation species. They support a ton of wildlife. They are really important biodiversity for biodiversity in California. What can we create a project where we think about what's the potential for incorporating oaks back into that landscape where they've been lost on the order of 90% declines from what was historically there? So we asked, how has this landscape changed over time? What does the urban landscape look like, and what is it providing now in terms of habitat support? And what actions could we take to restore this lost ecosystem? As I said, the valley floor was dominated by valley oaks, which is different from the hills, which were mostly coast live oaks. So this is a unique ecosystem that has been lost throughout California because valley oaks live in unfortunate locations where they're in conflict with people for agriculture and for cities, and so they're at a real threat for habitat loss and are of conservation importance because of that throughout the state. As we know, California oak woodlands in a general way are really important. They're the most diverse ecosystem type, the most diverse habitat type in California. They support exceptionally high wildlife diversity, including 5,000 insect species, 300 vertebrates. This is just what's been cataloged. There's probably more. And a really important note here is that because oaks have a really high tannin content, the tannins in their leaves impede consumption by a lot of insects. And as a result of that, there's deep coevolutionary relationships where insects have evolved capacity to cope with those tannins. And as a result of that, there's a large number of insects that are highly specialized, that they can live on oaks, but they can't live very easily on other things. And so that means that it's not easy to substitute the functionality of an oak with another tree because of the high degree of specialization and deep co-evolved relationships between wildlife and oaks that is, millions of years in the making. And so we know oaks are important for those reasons, but there's also structural features that are important too. So there tend to be, in oak woodlands, there tend to be many large dead trees, many large trees that host a lot of wildlife. There's accumulation of leaf litter under the trees that enhances soil fertility. Down logs tend to persist. They provide cover and habitat for wildlife. And so this is just some examples of that. So there's cavity nesters, Andy Trotter, this is your work too. Cavity nesters they do the excavating, and then the cavities that they excavate get occupied by other birds that can't build the cavities but really need them. And these are two examples. And then the leaf litter is important for soil fertility and habitat creation. So we took a couple of different data sets, including a data set a really unique data set of all of the front and backyard trees in the city of Palo Alto that was created by Canopy, and we used it to assess change over time. So we had a data set from the 1850s collected by the predecessor to the Bureau of Land Management that gave us really key information about the species composition and the age structure, the diameter breast height structure of the trees historically. So we used that as comparison to ask how the forest has changed through time. And so what we found was that valley oaks, in terms of size, valley oaks are kind of similar on the urban landscape to the past. But coast live oaks, there are fewer large trees on the urban landscape than there were historically. And that probably makes sense to you. But then when you look across all trees, we found that there's been a really substantial decline in the number of large trees on the landscape. And as I was saying earlier, the large trees are important for habitat support. We also used one of iTree's tools, the iTree Canopy software tool, to assess land cover classification and in some cities in Silicon Valley. And what we found here was that the tree canopy cover is about a little over 20%, and that's consistent with that oak savanna mixed habitat that was present in the 1850s. But there's been a huge decline in the herbaceous vegetation, sort of the understory, what would have existed between the trees. And that probably makes intuitive sense because buildings and lawns and impervious surfaces have replaced that ecosystem component. And so that piece is kind of really missing from the landscape today. We also found this incredible shift in species composition. This is probably also no surprise to you. So we went from a historical tree canopy that was dominated with 80% native oaks of just 3 species, and then another 13% was associated oak species like madrone and buckeye that live in oak woodlands with oaks. And then about another 7% was other California native species like redwood is the biggest piece of that. So we went from that oak woodland ecosystem in the past to the contemporary landscape where there's on the order of 400 different species. No single species is more than 8% of the total, and the native oaks are about 4% of the total, and the other associated species are less than 1%. So this is a huge shift in the species composition of this forest. And so that's the really brief overview of re-oaking, sort of our findings. We went on to try to translate that into some guidance. So we said, here's the type of things that you could do to integrate oaks back into the urban landscape. You could create oak nodes where nodes of oak planting that are 1,000 feet in diameter, and those plantings would, maybe include a bunch of different houses in people's backyards and a street tree program. And those nodes could be centered around a large tree that could act as a kind of focal point and could be the granary tree for an acorn woodpecker colony. And you could do other things like try to make sure that you had at least 20 trees. You could try to make sure that the trees were at a distance of 500 feet apart from each other so that trees of the same species could pollinate one another. And this is important because pollination is key to creating acorn crops, and acorn crops are really important for supporting wildlife. So we have some other guidance and recommendations that kind of push this into, well, how could we integrate this into the urban forestry, into urban forestry programs, and also how could people's backyards and other types of land uses integrate with the urban forestry programs to kind of make oak plantings that could work synergistically together to support biodiversity. So that's the broad overview. But what I want to do now is just identify some questions, because in the past year since this report has come out, we've talked to a lot of people in the urban forestry community, and this has given us a sense of what the challenges to implementation are. And so what I'm going to do is just kind of go through those, and I'm going to just offer a couple of words about each of these questions, and then we can kind of take that as a jumping off point for a discussion. So the questions that we've encountered are, well, why should we care about native trees versus other trees? Like, all trees have ecosystem, or provide ecosystem services and are important in the urban landscape. The second question that we encounter a lot is, well, what about diversity? Because a core tenet of urban forestry is to maintain a diverse forest as a risk reduction mechanism for guarding against pest outbreaks that could wipe out the urban forest. Another question we've got is it going to work? There's a lot of barriers to getting oaks into small spaces. Is this landscape really appropriate now, given all of the changes that have happened? And then the final question is, what about climate adaptation? And so that's obviously a real key thing on everybody's mind, is like, what are the trees of the future going to look like? What is going to be the appropriate species that we need to plant in order to make sure that they can be adapted to the climate that's coming? So I will run through briefly each of these questions and highlight the things that basically what I think about these questions, and then we can kind of talk about it a little bit. So in terms of why natives, the best argument for why we should care about native trees is really the wildlife or the biodiversity argument. But the problem with that argument is that people don't care, right? Like, some people care about wildlife, but not everyone cares about wildlife. And so that as an argument on its own is maybe not a good enough argument for people, for you, is also not a good enough argument for the public. So we need to have something else to say about why native trees are important if we think that they're important, or if we can all agree that they're important, at least as some component of the urban forest. But some other arguments that you could make is that they're very drought tolerant. Native trees in California are adapted to the climate, and that is a good thing, even though the climate is changing, and I'll talk about that more in the climate adaptation section. We've done some analyses that I'll show you some figures from, where we found that in terms of ecosystem service provision, the native oaks are actually really punching above their weight. They're really, really good at providing a variety of different ecosystem services, and so there's an argument to be made there as well. There are human health benefits associated with biodiversity that I'll also mention, and they have a role in reducing biotic homogenization. So this is the idea that the same trees and the same horticultural varieties of landscaping plants are being planted throughout the United States in every city. And that is going in parallel with a trend towards cities having the same kind of character to each other. So every city you visit in the U.S. has the same sets of strip malls and the same sets of big box stores and the same types of architecture. And so when you travel in the world, each city looks like every other city. And the reason that we think this is important is because people come to San Francisco from around the world because it's a unique place, because it has unique architecture, and because it's beautiful. And I think that the native ecosystems also can play a role in reducing that and in growing that sense of uniqueness that cities can have, because people love oak woodlands, people love to visit them, but that character of oak woodlands that's so distinctive and so sort of characteristic of California ecosystems is not represented in California cities. And if it was, it could actually play a role in that uniqueness, so that when you travel in the world, each city doesn't look like every other city. And then there's the conservation value. So conservation of oak ecosystems is a huge deal in surrounding landscapes outside of cities. And so to the extent that cities could contribute to those broader conservation goals for oak woodland ecosystems, that could be a good thing. And then there's the cultural value that I just touched on, that people really care about that native heritage of oak woodlands ecosystems. So in terms of carbon sequestration, or in terms of ecosystem services, we have looked into this for the re-oaking report, and what we found was that coast live oak is a huge carbon sequestering tree, and over the 45-year lifespan of a tree, it's doing better at sequestering carbon than basically all the other 10 most common trees in the Silicon Valley street tree inventory. And so these are kind of machines for carbon storage. We also have looked across other benefits. So this is a project that I did in collaboration with a bunch of graduate students from Cal, and taking a conservation biology course. And what they did was to use the street tree inventories from Silicon Valley that we had access to look at the ecosystem services provided by native trees versus non-native trees using the iTree software tool. And for this analysis, we sort of jerry-rigged iTree, and we created dummy data sets of trees from 0 to 50 inches in diameter at breast height, and we sort of forced iTree to tell us, like, what are the ecosystem services provided by these trees that are similar in every other way except their diameter breast height and their species. And what we found was that the important point is that the native trees have a steeper scaling relationship. So they're growing, they have more benefit for a given diameter breast height, and that accumulates quicker as the trees get larger than the non-native trees. And this is a comparison between 15 of the most common trees in the urban forest and the native trees, which are mainly oaks. And then if you look, that relationship is also replicated when you look at each of the individual ecosystem services. So similar for carbon sequestration, avoided runoff, and pollution removal. This student group that I was working with, they also took the WUCOLS data set, and they said, okay, comparing these same 15 native species and 14 common native species by water use level, how do the native trees stack up against the non-native trees, and this is the WUCOLS database is pretty broad categories. It's just very low water use to high water use. But what you can see is that there are more native species in the very low, low, and low category, and more non-native species in the moderate and high category, suggesting what you might already know, which is that the native trees are pretty adapted and drought tolerant to our landscape. So in terms of human health, we all know that nature is doing good things for us, and the urban forestry community has been important actually in pushing forward some of this research, evaluating the effects of nature exposure on us. And the book, The Nature Fix, is a kind of accessible to a non-scientific audience summary of that research, which is really robust and growing really rapidly. But the thing that you may not know is that in addition to the finding that nature in general is good for us, there's also a subcategory of that research that is also showing that it's not just nature, but it's biodiverse nature that gives us good benefit. And there's two kind of categories of research that have found this. The first is that it's been found in quite a lot of studies already that the restorative benefit that you get from being out in nature is greater if it's biodiverse nature compared to just turf. You know, like you go out into a city park and it doesn't have very much biodiversity. You actually get less of a psychological benefit in terms of your feelings of well-being and feelings of restorative kind of benefit than in low diversity comparisons. And there's also really kind of out there and on the fringes, so to be taken with a grain of salt, but incredibly interesting body of work that's looking at microbiome rewilding. So you may be familiar with the importance, with the kind of growing recognition of the importance of our microbiomes in making us healthy. And this is for, there's kind of a body of research that's documenting that is hypothesizing that the growing incidence of diseases like allergies, chronic diseases like asthma, obesity, allergies, could all be related to essentially our environments being too clean and us not having enough of the right microbiome that we need to prevent those, to create good immune system functioning that then prevent these chronic diseases from happening. And so there's some research going on that's looking at, well, maybe exposure to biodiverse ecosystems and biodiverse nature could help with getting the right microbiome recolonized in us in order to prevent those problems. So that's on the fringes, but potentially super, super interesting and compelling. Okay, so what about biodiversity? So as I was saying, this appears to me to be one of the biggest barriers, is that we sort of encountered this question a lot, is, well, but we need a diverse urban forest, so are you really recommending that we go back to the past, to that ecosystem that had basically 3 trees in it? Like that's not a good idea. And I think the best thing that I can say about this is that, yeah, that might not be a good idea, but the reality is many cities have, like I was showing you earlier, less than 4 or sometimes 2, like really, really, really small numbers of native trees. And so you could substantially increase the number of native trees on the landscape and still not reach any of those thresholds of 10% of one species or 20% of one genus. Another thing that I think is important to point out here is that non-native trees are not necessarily protected from pests. There's kind of a well-substantiated body of ecological research that has shown that one of the reasons exotic species do so well in their novel habitats is because they've escaped from the pests and predators that attack them in their native ranges. But the thing is that is changing as global transportation is moving organisms around. So the more opportunity we have through global transportation to introduce more and more pests, the less likely it is that non-native trees will be protected from pests by basically just not having their pests around, if that makes sense. So that's an important point to note, is that yes, non-native trees may in some sense be protected from their native pests, but not if we continue importing those native pests from around the world into places like the Port of Oakland. The other really important point I think to make here is that drought-stressed trees are much more susceptible to pests. And so if the strategy is to increase the diversity of the urban forest, if that strategy includes planting trees that are not drought resistant, then that could backfire. The strategy of biodiversity could backfire because those non-drought resistant trees could ultimately be more susceptible over time to those drought events that will be increasing, as we all know, with climate change. Will it work? So here, we don't have a ton of data on this question, but I would love it if anyone can point me to a data set that would help address this question more fully. Here we've sort of encountered people saying, well, the spaces are too small for the trees, and are the trees going to do well if you plant them? And we should really be planting small trees in small spaces because those are the trees that succeed. And I think to some extent that is of course true, but I am curious to kind of look at to try to think about outside the box about how streets could be redesigned to accommodate larger trees, and then how we might make small spaces able to accommodate large trees in spite of the fact that they're small. I think those are maybe two important points that could be made that are worth talking about. And so this is like anecdotal, you know, so we've just been photographing oaks in small spaces and oaks across the urban landscape, so this is just some examples of that. I also have done a tiny bit of data analysis to look at this question from the street tree data inventory from the city of San Jose. This is 247,000 trees. And I'm just going to show you one figure that should be taken with a huge grain of salt. Basically, what I did was just to ask across this whole data set, are the non-native trees in as good a condition as the native trees? And it's worth pointing out here that the native trees are 2.5% of the total, and the non-native trees are 97.5%. So there's a huge difference in sample size. But so all I'm showing here is the percent of trees falling into each category. And what you can see is a relatively even, like, there's similar numbers of dead and dying trees, similar numbers of fair and good condition trees across these two categories. But the reason I want a big caveat here is because you're probably already thinking, yeah, but the street tree inventory isn't telling you about the trees that were removed. And in the absence of that information, you have to be wary of how you interpret this. So if any of you have access to a data set like that where we could evaluate this more further, I would be really interested to hear from you. So in terms of finishing out with climate adaptation, the core questions with climate adaptation is, will the future be appropriate for oaks? And then a second line of question that we've had is, should we be bringing southern oaks to the Bay Area? Like, should we be doing assisted colonization to try to do range expansion for the trees that are need to move northward but may not be able to do it on their own? So I'm just going to show you just a little bit of my thoughts on this. This is the tool CalAdapt shows you climate change scenarios for the changes in climates for a particular area. So this is for Sacramento. And this is just showing that from now until 2080 and beyond, we're looking at an increase in temperatures from about 74 to about an average of about 78 to 80 degrees. So fairly significant shifts in climate are predicted in terms of maximum temperature. But for precipitation, the main predictions is not a huge difference in the amount of precipitation, but a potential difference in the distribution across the season. So fewer large storms, fewer small storms, more large storms, and more sort of extreme storms that can lead to bigger flooding events and things like that. And so this is data from the Forecast project, and this is a tool that uses species distribution modeling to predict the range expansion or the range contraction of forest of like 400 or 500 tree species across the U.S. And you can use it as a tool to sort of ask the question, what's the range of my species now, and what is the range going to be going forward? And so this is using like the PCM B1, like kind of a middle of the road scenario for what might happen in the future. And this is, I apologize, it's actually going out to 2100. And the point here to make is just that you see for coast live oak and valley oak, you do see range expansions northward, but you don't see contractions away from the Bay Area. So it's not that the Bay Area is, in Silicon Valley in particular, is going to become unsuitable over time for oak trees. Though in Southern California we may have some shifts. So the green there is the current range, and the red is the future range. So there, on the whole, throughout California, there will likely be a sort of shift northward in the area that's appropriate. But for Silicon Valley in particular, it's not that this landscape isn't necessarily going to become inhospitable. And this is for Engelmann oak. This shows a pretty significant expansion of its range. Blue oak showing expansion also, and then similar patterns for the other, for interior live oak and black oak. And so the kind of point here, going back to the assisted colonization point, is that it could actually be useful to think about whether assisted colonization is a worthwhile process, because urban landscapes, we have the capacity to intervene a lot in urban landscapes. And if we can move trees that are going to be expanding their range northward through planting in urban forests, that actually could be a helpful kind of conservation goal for trees that are going to have trouble keeping up with the pace of climate change going forward. Okay, so with that, I'll finish, and we have 15 minutes or so to discuss or to answer questions or just to have a conversation. Thank you. I should also acknowledge my funder, our funding here from the Google Ecology Program and the Peninsula Open Space Trust.
Hello? I'm sorry, you talk really fast. I don't know if that's just me, but did you say that the blue oaks are expanding their area?
Mm-hmm.
Okay, that's cool.
If I go back? Yeah.
Yeah, so that could be a good tree to plant, right?
Mm-hmm.
That sounds like it would be a good tree to plant, and it makes sense looking at the leaf of, I'm an arborist for 20 years, and it makes sense that that tree would be the one that it's really interesting. Thank you.
Yeah, blue oak is one that gets brought up a lot because it's really drought tolerant. It might, it could be a good, particularly in urban landscapes and in your hottest sort of environments, like maybe blue oak could be a good candidate.
I have a question. What's the next step? You talk about reoaking Silicon Valley. Have jurisdictions looked at this and changed what they're doing? If you talk to Caltrans about it, what can you tell us?
Yeah, like what's happened since then. Canopy is actually one of our main implementers of reoaking. They're doing some reoaking in Palo Alto. We also have a grant through the Environmental Protection Agency to do some implementation in the city of East Palo Alto. Google has been huge. Google's done an incredibly huge amount of reoaking on their corporate campuses in Mountain View and going forward into other places as well as they're expanding their campus. And then we are working with the Santa Clara Valley Open Space Authority to integrate reoaking concepts into their urban open space granting program, so that when you apply for a grant through their program, you have an incentive to try to integrate some of these concepts into your proposal to increase its probability of being accepted. So that's a sort of programmatic pathway that we've managed to develop for reoaking. But it's still pretty early stages, and we're really looking to see, like, how can we move this now that we've got this like a science foundation. There's still like a translation into these different sectors step and also an implementation step. And we don't do implementation at SFEI, so it's really we depend on our partners to kind of work with us to figure out how they can implement some of the science that we're synthesizing and make it actionable on the ground. And we're excited about any new opportunities that we could have to do that, but it's still pretty early stages at this point.
Thank you very much. Very good presentation. I have one question, because one of your slides has a number about the comparison between historical data and the data we have now, the modern data. Mm-hmm. And for two oak species, one is valley oak and the other one is coast live oak. And based on the number on that slide, and it's very interesting because for the valley oak, the number from like 21 actually increased to 24%, but for the coast live oak, it dropped from 22 to 10%. So I just wonder, have you explored why for these two like oak species, and why it's so different? Because one of them reduced significantly, but the other one actually increased a little bit.
A small increase in the large trees. Yeah. I don't know. So this is from comparing historic data to the canopy survey that I was telling you about that surveyed over 4 years all of the oaks in people's front yards and in people's backyards. And I think that the reason for this is because when you include people's backyard trees, there are more large trees. So the majority of the large trees in Palo Alto, at least, and it's probably generalizable, are in people's backyards. They're not in the street trees. And valley oaks are more likely to be backyard trees than coast live oaks. So coast live oaks are a relatively common street tree, but valley oaks are not. And so I think the reason for this is because the larger valley oaks are being protected in people's backyards. The coast live oaks are mainly street trees, and those tend to be smaller. Does that? Oh. That is a good point, though they're both protected in Palo Alto. But yes,
so would that be helpful for like a future conservation? Because as you said, you know, when we engage with homeowners, when the oak trees are in their backyard, actually, it's very likely they will be protected or maintained. Would that be something helpful for future conservation? What do you think?
You mean working with homeowners?
Yeah, because
is that your question?
Yeah, because you said it's very like if they're on street and maybe, you know, for some reason they won't be protected, but if you plant the tree in your backyard or your front yard, and it's more likely they will be protected.
Yeah.
Would it be something like helpful for future conservation? We could engage it like homeowners and to like plant more oak trees.
Yeah, absolutely. I think planting oaks in people's yards is definitely a pathway for re-oaking, but this is a really good point that you actually might get better conservation of those trees when they're in people's backyards compared to street trees. I'd be interested to hear. You probably would know the answer to that better than I do, but it seems like yeah, probably, especially if you have heritage tree programs that could also incentivize protection of those trees.
Yeah, thank you. And just to jump in on this as well, it also is important to note that if you look at the really small diameter trees in terms of valley oaks, it really drops off. And those large diameter trees aren't going to be around forever. So it's important to keep that front end loaded, you know, to ensure that we have kind of that back end.
Yeah, and you don't see that with the coast live oaks. That drop is concerning with valley oaks because it means those trees are not being planted. It's a really important point. Yes.
Oh, can you hear me? Great. So my question is about like the assisted migration theories or strategies that we're talking about, moving species from south to north or from one area to another. I know that in San Francisco, one of the only like native trees we can plant is the island oak, the Channel Island oak, and I know that that's because of our environmental conditions. I know that Canopy has been planting Engelmann oak, which is from San Diego all the way up in the Bay. And my question is more related to like the functionality of those species. Is there an idea about, you know, we're talking with the oak nodes of making sure things are close enough together so you're actually creating like assisted wildlife corridors. You know, is there a theory or idea about how far things need to be or how close together you need to like create a continuous stream of these species so that their associated insects and animals can move with them? Or are they like, is Engelmann oak, is Channel Island oak like at a close enough approximation so that the plants and animals and bugs can actually work with them rather than needing to replace all their associated bio?
Yeah, I think you asked two great questions there. One is, will the southern oaks perform the same ecological functions for the species that are already here? But you're also asking a separate question about what you need to do across the corridor from south to north of California to make sure that you have stepping stones along the way so that wildlife can move along with them. I think that's what you're saying, right? Yeah. So to the first question, I would say we don't entirely know how an Engelmann oak, like, will it support the same wildlife as a coast live oak? We don't totally know the answer to that question because there isn't a lot of research on that. But I guess what I would say is that what we know in general from ecology is that a species that's very similar in the same genus and is much more likely to perform those functions than a totally, like a Chinese pistache, for example. To the second question, yeah, ideally you would have kind of stepping stones along the way from south to north. So that would mean engaging cities in lots of different places in these kinds of actions, which would be amazing. Yeah. Yes, back there.
I'm just wondering if you considered fire suppression or an oak's threshold to fire. I mean, clearly that's an issue that's been occurring all throughout the state, and that, yeah, I don't know if that was included in any way in your research.
It wasn't in the research for the report that we've produced, but we've been thinking about it particularly since the Napa fires. Yeah, we are thinking about it more now. What we know is that oaks are really fire resilient. So if you have an oak in your yard, it's less likely that it was damaged and killed by the fire. Like they can lose almost their whole top and then resprout from the base. They're adapted to living with fire. But there's a kind of separate question that we don't totally know the answer to, which is you also, PG&E actually has been instrumental in trying to come up with guidelines for how you reduce the hazard of your house burning down, particularly if you live in the wildlife-urban interface, or the wildland-urban interface. And so there's some guidance about how you manage the defensible space around your property to make sure that you reduce the hazard of your house catching on fire. And oaks, I think, are a part of that story as well, that we don't totally know how oaks would fit in. Like, what's the distance back from your house you need to make sure you plant an oak? I think we should be thinking about that, but we haven't done very much yet. Yes, back there.
So from a residential shade tree program perspective, and I don't know if there's any research, but anecdotally, a lot of our constituents don't want oak trees, right, because of protected statutes. And so I don't know if there's any recommendations y'all have come across or ways to incentivize planting of natives so that people will be willing to overcome that, because they don't want to deal with the cost of maintaining a removal that would come with it after it's planted.
Yeah. I will tell you a small back to the theme of human connections, I'll tell you a small human connection story, and then I'm going to ask the question back to you. So we removed our garage last summer. I live in East Oakland, near Mills College, and our garage was like falling down, and we couldn't get it. It was not possible to replace. Whatever, not important, but we decided to just remove it and to create more space for having our yard. And I was like, great, let's plant a tree. And I have been in a year-long fight with my husband about whether we can plant an oak tree in our yard, and I'm losing that battle. So I know what you're talking about. I have heard every possible pushback against the oak tree, including the prickly nature of the coast live oak leaves, which you may have encountered. So yes, I've encountered that from my husband, but also from other people as well. I think that you might be in a better position to tell me what you think about that than I am. I'm not entirely sure what the answer is, but I don't work directly with the community in the same way that you do. So the kinds of arguments that need to be made in order to incentivize people to change their mind, I think you guys are the experts on that. So I'm really curious to hear what you think. Anybody else want to? There's some excited hands.
That issue come up where Canopy wanted the city of Palo Alto to plant oak trees as street trees, and the the chief forester said, well, they're too big to put in the, and Catherine brilliantly said, well, by the time they get too big, we won't be here. So they don't have to worry about it. And it actually worked. That worked.
You know, yes, that's a great point. Can I add on that just a little bit? So for the small space argument with oaks, I've heard two kind of compelling things recently that give me a new way of thinking about this. So one is that Jimmy Shade, I saw him give a talk to the Forestry Council in San Francisco, and he talked about the need to think outside the box about the transition of streets. So we're not just continuing to think about putting trees in 3-foot boxes forever, that we want complete streets. We are going to be transitioning to a new model of how our urban landscapes look, and this is an opportunity to change how we're thinking about how trees are integrated. So we're not just thinking about them in these tiny little boxes, but we can motivate change towards creating bigger spaces for trees. So I think that's one thing. The other thing is that I saw a talk at the Western Chapter of International Society of Arboriculture last week about it was about protecting large trees, protecting mature trees, but the presenter gave a really interesting kind of perspective on the different longevities of trees, and he was pointing out that the plum, the purple leaf plum, has a lifespan of about 25 years. And so if we're planting trees that only live 25 years in those small spaces, why not just plant an oak tree and let it live for 25 years in that same space? It's not going to get that big over that time. So it's maybe a different way of thinking about the space constraints. Yeah.
You know, this is actually a follow-up question. I love big trees. And as I mentioned, I got the Cupertino City Council to adopt a policy about having developers plant the biggest species possible. And our public works director is really a fan of complete streets. My question is kind of advocacy. Can we get on the agendas of conferences at, say, the American Society of Landscape Architects, the American Public Works Association, the American Planning Association, and even Caltrans to have the same kind of policy about space for big trees and a policy about planting them?
I completely agree. We are trying to make headway in all of those areas. Yeah, I think it's really important. If you can help us do that, we would love to join forces. Yeah.
I'm a nursery grower, and Quercus agrifolia is one of our most popular varieties of trees, and they go all over California, but we grow probably 30 times more Quercus agrifolia than we do lobata, because that's where the demand is.
Yeah.
So I do think a lot of people are using Quercus agrifolia as a street tree. And they're being used on large estate properties and things like that, Google, but we grow an awful lot of Quercus agrifolia, so I think that's a good sign.
Yeah, that's great. Thanks. Thanks.
In Sunnyvale, the question came up as to the use of our golf courses because they're not being used as much as in the past. So one of the council members came up with the idea of making a forest out of the golf course, which I think would be a great idea, and it'd be great for our large trees. They are going to look into this if the golf courses still can be used as golf courses, but if not, it might be a future consideration to make forests out of these golf courses.
Is there potential for that land to actually be acquired? Yeah, that's great. Is there potential for that land to actually be acquired as a municipal park?
It's owned by the city.
Is this the one right by Moffett, just south, just kind of in the western part of Sunnyvale? Okay. Okay, yeah, that's great. Okay, well, it's 12:05. We should probably wrap up and have lunch. This was really, really fun, and I look forward to having more conversations with all of you over the next few hours. Thanks so much.